In the heart of the American West, a landscape unlike any other unfolds. Steaming vents hiss secrets into the crisp mountain air. Turquoise pools shimmer with otherworldly colors. Geysers erupt with primal force, painting the sky with columns of scalding water. This is Yellowstone National Park, a place of unparalleled beauty and raw geological power. But beneath this vibrant surface, a colossal secret lies hidden. A sleeping giant. What forces stir beneath this iconic wilderness? And could it truly awaken? What we see at Yellowstone is merely the skin of something far grander, far more ancient. A massive depression, barely visible from the ground, defines the park's core. This is the Yellowstone Caldera, a scar on the Earth's face, formed by unimaginably powerful eruptions in the distant past. It stretches vast distances, a silent testament to an immense power that once ripped through the continent. But the true story, the deeper mystery, lies not just in its size, but in what lies beneath it. Deep below this caldera, thousands of feet down, resides the engine of Yellowstone. Not a single, simple chamber, but a vast, complex network. The magma chamber. It's an immense reservoir of molten rock, partially solidified but still incredibly hot and volatile. This isn't just a pool, it's a dynamic system. Far larger than anyone initially imagined, this fiery heart fuels every geyser, every hot spring, every whisper of steam across the park. Its scale is almost incomprehensible. Yellowstone's history is written in cataclysmic events. Over the past 2.1 million years, this region has experienced 3 super eruptions. Each one, a geological epoch. The first, creating the Huckleberry Ridge Tuff. Then the Mesa Falls Tuff. And most recently, the Lava Creek Tuff, forming the main Yellowstone caldera we see today. These weren't mere eruptions, they were continent-shaping events. But when was the last time? And what does their pattern tell us about the future? To understand the giant below, scientists listen. Constantly. Deep within the park, and across the wider region, a network of highly sensitive seismometers records every tremor, every slight vibration. These instruments are Earth's ears, listening to the rumblings of the magma chamber, tracking the movement of fluids, the shifting of rock. Most are tiny, imperceptible to humans. But together, they paint a picture of ongoing, dynamic activity. A constant, subtle pulse. Listening isn't enough, scientists also watch the ground itself. GPS receivers, spread strategically across the caldera, measure minute changes in elevation and horizontal position. Is the ground rising? Sinking? Moving sideways? These precise measurements reveal the inflation and deflation of the caldera, directly linked to the pressures within the magma chamber. It's like watching the chest of a sleeping giant, observing its breathing. Tiny movements, yes, but significant over time. The magma chamber also communicates through gases. Invisible plumes of carbon dioxide, sulfur dioxide, and other volatile compounds rise from the ground, especially in geothermal areas. Scientists collect and analyze these gases. Changes in their composition or volume can signal shifts in the underground system, perhaps new magma moving, or different depths of interaction. It's a chemical signature, a faint breath from the Earth's fiery lungs, telling a complex story. Beyond tremors and ground movement, temperature also plays a critical role. Sensors monitor heat flow, water temperature in hot springs, and even the electrical resistivity of the ground. Anomalies in these readings could indicate rising magma, or changes in the hydrothermal system. This holistic approach, integrating seismic, geodetic, and geochemical data, provides a layered understanding. It's a symphony of data, each instrument playing a part in revealing the supervolcano's current state. The iconic geysers, like Old Faithful, are not just tourist attractions. They are vital windows into the plumbing of the supervolcano. Their regular eruptions are driven by heated water interacting with the deep magmatic heat. Small changes in their eruption patterns, in temperature or chemistry, can offer subtle clues about shifts occurring beneath the surface. Each gush of water, each column of steam, is a message from the depths. A constant, mesmerizing reminder of the power below. And then there are the hot springs, vibrant pools of every imaginable color. Grand Prismatic Spring, with its fiery rings, is world-renowned. These colors are not from minerals alone, but from thermophilic bacteria and algae thriving in the extreme temperatures and unique chemical environments. These springs, too, are fed by the supervolcano's immense heat. They demonstrate the incredible energy escaping from the magma chamber, a continuous release that prevents catastrophic pressure buildup. Yellowstone also hosts a fascinating array of mud pots and fumaroles. Mud pots are acidic hot springs that dissolve surrounding rock into a thick, bubbling mud. Fumaroles, on the other hand, are steam vents, where superheated water flashes to steam before reaching the surface. These are more direct emanations of the supervolcano's heat, evidence of water encountering extreme temperatures at depth. They are a raw, visceral display of Earth's internal processes, a reminder of the power always at play. All these surface features, the geysers, hot springs, mud pots, and fumaroles, are interconnected. They are the visible parts of a vast, complex hydrothermal system. This system acts as a release valve for the underlying magma chamber. Water seeps into the ground, is heated by the magma, and then rises back to the surface. It's a dynamic, circulating system that has been active for millennia. A continuous process, perpetually releasing the heat and pressure that define Yellowstone. It's common for Yellowstone to experience numerous small earthquakes, often hundreds in a week during a swarm. Most are too small to feel. These are natural adjustments of the crust, often related to the movement of hydrothermal fluids or slight pressure changes within the magma chamber. They are not, in themselves, indicators of an impending supereruption. In fact, they're a normal part of the Yellowstone experience, constant reminders that the giant is always active, but rarely destructive. The idea of Yellowstone erupting is often surrounded by sensationalism and misunderstanding. Myths abound that rising steam means an eruption is imminent, or that a large earthquake will trigger it. Science tells a different story. Significant signs, like sustained, widespread ground uplift over vast areas, massive increases in gas emissions, or changes in heat flow, would precede any major event. These would be clearly detectable, not a sudden, unexpected surprise. The giant gives many warnings. Should a supereruption occur, the immediate regional impacts would be catastrophic. The initial blast would devastate everything within tens of miles. A thick blanket of volcanic ash would then cover vast portions of the American West. Ashfall would disrupt agriculture, transportation, and infrastructure across multiple states. Air quality would plummet, and freshwater sources could become contaminated. It's a scenario that paints a grim picture for millions, a scale almost unimaginable in modern times. Beyond regional devastation, a supereruption could trigger global consequences. A massive injection of ash and sulfur aerosols into the atmosphere would block sunlight, potentially leading to a volcanic winter. Global temperatures could drop significantly for years, disrupting growing seasons worldwide, causing widespread crop failures and famine. It's a climate-altering event of profound magnitude, reshaping the very conditions of life across the planet. A true global impact. But for all the dramatic speculation, the scientific consensus remains clear: there are currently no indications that a supereruption is imminent. Yellowstone is a dynamic system, always active, always moving. But it has been in a period of relative calm for tens of thousands of years. The frequent small earthquakes, the rising and falling ground, these are its normal state, its regular breathing. The giant sleeps, but its dreams are vivid. The dedicated scientists of the Yellowstone Volcano Observatory, a collaboration of federal agencies and universities, tirelessly monitor every signal. They use every available tool, from satellites to ground sensors, to understand the giant's pulse. Their mission: to distinguish the normal, vital signs of a restless caldera from any ominous precursor. Their vigilant watch provides critical reassurance and essential data, ensuring that humanity is not caught unprepared. Geological time operates on scales far beyond human comprehension. The intervals between Yellowstone's supereruptions stretch for hundreds of thousands of years. The last major eruption was 631,000 years ago. While Yellowstone remains a powerful, active supervolcano, its cycles are measured in epochs, not decades. We are merely a blink in its vast, slow-moving story. The forces at play are immense, but their tempo is deliberate, unhurried by human timescales. Yellowstone, a place of profound beauty, deep mystery, and immense power. Its supervolcano is a constant reminder of the dynamic, living Earth beneath our feet. We may not fully comprehend its ultimate fate, but through science, we gain insight, respect, and a vigilant understanding. The giant sleeps, watched by human eyes, its breath rising in steam and its heart pulsing in tremors. A natural wonder, a geological marvel, an enduring puzzle. Could America's sleeping giant awaken? Only time, in its geological grandeur, will tell.